Alright, so I am by myself today, but that's not going to stop us from looking at some sensors on this Jeep. This is the 99 Grand Cherokee with a 4.7 liter V8. So, we are going to be looking at the camshaft sensor and the crankshaft sensor. Now, since this is a V8, we do have overhead cams on both banks, but specifically, this only has one camshaft sensor. It is located way down in there. I don't know if you can see it. You might be able to see the connector for it right there. That is your camshaft sensor. It is on the right side, bank 1, and there is not one on this side. Now our crank sensor is a little bit harder to get to, but that's why we have all data. So we can go take a look at where it's located. So on this vehicle, it is located directly above the starter on the back of the engine. Another thing about ALLDATA is it tells us some really good description and operations of both of our sensors. As you can see here, it mentions that our crank sensor is a Hall effect device that is combined with an internal magnet. And as you can see, it is based off a tone wheel that is connected directly to the crankshaft rather than the flywheel. Now, looking at this sensor, you can see we can confirm it is Hall effect because we have 3 wires. A 5-volt supply, which is pin 3, a sensor ground, which is pin 2, and the sensor signal, which is pin 1. The camshaft sensor, we also get some pretty good information. As you can see here, through our components, we have a tone wheel that is integral to the camshaft on top of the motor, as well as it mentions that it is also a Hall effect device, which creates a sync signal. And this is used to create and operate the fuel set injector signal, as well as it mentions how many notches our camshaft should have. So we should have, in order, 1 notch, 2 notch, 3 notches, 3 notches, 2 notches, 1 notches, 3 notch, and then 1 notch. And then looking at our wiring diagram, we also can confirm it is Hall effect by the fact that we have 3 wires, a 5-volt supply, a sensor ground, and the signal. So, knowing this, we should know that both of these will have a square wave signal. Okay, so I've gone ahead and unplugged our camshaft position sensor. We are sitting key on, engine off, and we're just going to do some basic voltage checks to see, make sure we have 5 volts and ground to it. I'm hooked up to our picoscope here because I do not have a multimeter with me here today, but this will do the same thing. So we know we should have 5 volts on our orange wire. So if we very gingerly go ahead, and I'll pan you guys down there so you can see, and very gingerly front probe our orange wire here, which I am struggling to do one-handed. There we go. See, we spike up to 5 volts on this scale over here. And if we go ahead and go into the middle wire here, this should be our ground. And it is. As you see, we've gone back to 0 volts. So we know we have good power and ground. The crankshaft position sensor, you'll be able to test it very similar way. You have 1 power wire, 1 ground wire, and 1 signal wire. However, it is not easily accessible on this vehicle, so I will not be showing it in this video, but it is the same exact steps. Okay, so right now we have the picoscope hooked up. We have 1 lead on ground and 1 lead probed into the PCM, because the crank sensor is a little bit hard to get to. Actually, no, the cam sensor, sorry, correction. We are looking at the camshaft sensor. So, we are probed into pin 18, which is a tan and yellow wire on our black PCM connector. I'm gonna go ahead and fire up the vehicle here and see if we have a good tone signal. The vehicle is running, and we are getting a signal. Let's adjust our time a little bit so we can get some good divisions. Just go along that. There we go. Go ahead and stop our waveform. You'll see if I move our ruler here, we do peak at about 5 volts there. And we do have a pretty good looking signal. We have 1, 2, actually here, let me get a better pointing apparatus. We have 1, 2 notches, 3 notches, 3 notches, 2 notches, 1 notch, 3 notches, 1 notch, and then it starts over. So this does look very good, and it is reading exactly what our service data told us we should be seeing. Okay, so now we are connected into our crankshaft position sensor. We are once again on ground, and this time we have a pretty convenient test location here, that since this is a lab vehicle. But this is the gray with black wire off of the black connector, which is pin 8 here. And as you can see, key on engine off, we maintain about 5 volts, which is different from the other one. So I'm gonna go ahead and fire it up again. And with it running, you can see we have a pretty consistent waveform. If I stop it, see we have about like this one kind of double hump. It's a little bit wider. 1, 2, 3, and then again another one that's a little wider, and then that continues for the whole waveform. So that's looking pretty good. Okay, so we're gonna go ahead and compare our two signals now. Our blue trace here is probed into our crank signal. Our red is probed into our cam signal. We have ground, obviously. So with our scope running, as you can see, the red trace, which is our cam, is at 0, and our crank is at 5 volts. I'm gonna go ahead and start up the vehicle, and we're gonna take a look at how these two compare. So starting the vehicle, you can see we have pretty good waveform between the two. I'll go ahead and stop it, and we'll zoom in and look at a section of it here. One full rotation roughly, right here. And I'll move it down so we can compare it a little better. But looking at it, as you can see, our wider trace here lines up pretty well with the start of our signal and the back end of our signal from our cam. So you can see it lines up with this one. This wider one lines up with our last one of the group of 3, and so on and so forth until our waveform restarts right here, where this would be the wider signal. So we are in correct timing with our cam and our crank right now. Okay, so right now we're sitting inside the vehicle. We're gonna look at these 3 data PIDs here: crank position count, cam position count, and the current sync status between them. If we go ahead and fire up the vehicle, you can see our crank position counter will start climbing pretty quickly. It goes to 255 before it resets, as well as our cam position count is also climbing until it gets to 255, where it will reset. You see our current sync status is okay. So this is whether or not we have a good cam and crank status at the same time. This just measures how many times it has counted them rotating. So not super important, but still good information to have. Okay, so right now our vehicle is running and is idling correctly. As you can see, if I come out here and I can rev it just fine. What I'm gonna go ahead and do is unplug our connector here for our crank sensor and see if she still idles without a crank sensor signal. I'm gonna unplug it. Whoa, we had a little stumble there. It's trying, but as you can see, without a functional crank sensor, it will still try to run and find idle based off the cam, but it's really not happy about trying to run without it. You come inside the vehicle, see our tach is still working, so I'm interested to know what that's based off of. And if we go to code menu here, so you can see if we go to codes, we have set a no crank reference signal at PCM, and it is really struggling to find its idle without the crank sensor. I'm honestly kind of surprised that it hasn't died yet. It is struggling. But yeah, that's almost impressive that it can do that, because it's still trying to find idle. It just, without any reference for how fast the engine's going, it doesn't really know. However, once you shut it off, see, the engine won't come back to life. It does try, but it doesn't do it very. It doesn't come back.